So today we're going through exercise 5A, and I've just said we're not going to really learn anything new today. We're starting applications of integration. It's a short, sharp unit, and basically 5A and 5B are going to be 5A, skills we know. 5B will introduce something a little bit new, but it's very easy to pick up. In 5C we look at kinematics, and then in 5D we look at problem solving. And that's the extent of applications of integration. So we'll get straight in here. We're asked to find the area under the curve 3x squared from 0 to 1. So we know already that the area under the curve from 0 to 1 is the definite integral from 0 to 1 of the function 3x squared with regards to x. Okay, so when we integrate 3x squared, we would get 3x to the 3 on top of 3. All right, this 3 is going to hang out the front. Integral of x squared is x to the 3 on 3. Those 3's can cancel, which will simplify our answer a fair bit. And we have from 0 to 1. So then it becomes 1 to the power of 3 take 0, which is 1. And because it's an area, we need to state units squared. So nothing really new there. What we've done here is applied the full fundamental theorem of calculus. Now, for a question like this, we're very happy for you to use your calculator. You're only required to show working if it says in the test, using the fundamental theorem of calculus. Now, when it says that, and this will be a bit of a prelude to your folio as well, there's basically a few things you need. The first is the integral statement. Okay, so that means we're finding the area. Then you've performed the integral with those boundaries. Then you've substituted them in. All right, and from between here and here, you don't need to show any working out. All right, you can just go final answer. Okay, so those 4 things are required. Sometimes in here, if you're doing it manually, it will require you to work it out. But this is where we've said it's much faster to just type this statement into your calculator and get that final answer rather than doing those sort of manual operations. Okay, let's move on to find K in the form C plus LNB, given the area under the curve y equals e to the 2x from 1 to k is 4e squared. So the first part is to understand this question. The area from 1 to k of the function e to the 2x with regards to x. Okay, the area under this function from 1 to k is 4e squared. So now it just becomes about solving for k. Now we saw some questions reasonably similar to this in our test just gone by. So the integral of e to the 2x will be half e to the 2x from 1 to k. Now this is one that we can't strictly use our calculator for because it wants us to find it in the form c plus lnb. However, you can actually type that expression into Equation Solver and it will give you the solution. All right, so your calculator can solve it for you, but it will give it to you as a decimal rather than in exact form. So that means when it tells us to find it in exact form, that means we're going to need to perform the algebra ourselves. Okay, we'll sub in the lower and the upper boundary, and we'll have e to the 2k, take half e to the 2, equals 4e squared. At this stage, I'm going to get rid of the half by multiplying both sides by 2. So we would have e to the 2k, take away e squared equals 8e squared. And I'll move this e squared over to the other side. So I'm going to plus e squared to both sides. And they are like terms, so they will collect. Okay, now we'll perform the natural logarithm of both sides. And so we'll have 2k equals ln of 9e squared, which we can split. Now I might come up here a bit because we'll just manipulate this a bit further. So we have 2k equals ln 9 plus ln of e squared. And ln of e squared simplifies to 2. So what we've got 2k equals ln 9 plus 2. We'll divide both sides by 2, or you can think multiplying by half. Half ln 9 plus 1. And half ln 9 we can express as ln 9 to the half, which is ln of 3. Alright, so we've expressed it in that form. C, that's our constant, plus lnb. So our constant term is 1, and we have ln of 3. That's going to be the exact value that gives us the area of 4e squared. So that's all we're doing in 5a. It's going to be a nice, pleasant exercise.